So for section 8.3, we're going to look at exponential functions. So an exponential function is super easy to identify just visually. So if we look inside of this box, we can see this function f of x is equal to b raised to the x power. So this is an exponential function because our variable is the exponent. We haven't done any problems like this so far, where the exponent is a variable. Well, this should be fun. So the only things that we have to really pay attention about when you have an exponential function here is that your base needs to be positive and that it can't be a 1. Those are the two characteristics. Now, the domain for our exponential functions is all real numbers. Okay, so examples of functions that are exponential functions. Well, you've got f of x is equal to 2 raised to the x. Okay, we've got f of x is equal to 1/2 raised to the power of 3 times x. Again, there's our variable. And then the last one, g of x is equal to a base of 7 raised to that expression x plus 1. Well, that's pretty cool. All right, so let's kind of explore these a little bit more. First of all, before we explore them too far, let's look at what do we get, or how do we do this with our calculator. Let's see if I can actually I could probably move my calculator over. Okay, so I've got 3 raised to the square root of 2. How do we put that in our calculator? So I'm going to put in the number 3. Oh, first let's turn it on. Okay, the number 3, that's our base. Then I'm going to use this upside down caret that's right above that addition sign. That'll allow us to put our exponent in. And so my square root sign is right here on my calculator. So to access that function, I hit second, and then this x squared key. That gives me my square root, and then I can put in the radicand of 2. Now I just hit enter, and it gives me my expression, or whatever, my decimal, which is going to be rounded to 4 decimal places. So I get 4.7288, and then there's a 0. That's my 5th spot is a 0. So because that after my 4th spot, that's what I'm rounding, I look to that 0 to make a decision. Do I need to add 1 to the 8 or leave it alone? Because that 0 is less than 5, I just leave it alone. So I'm going to take the 0 off. So my answer would be 4.7288. Now let's look at this next one. I'm going to move over my calculator. So that's 4 to the negative 5. So I'm going to put in my base of 4, and that is going to be raised to the negative. My negative is down here in the corner, negative 5. Then I press enter. All right, so this one is interesting because it gives me 9.765, and then this e to the negative 4. What the heck does that mean? So that is how my calculator writes this in scientific notation. It's saying this is the same as 9.765, and then it'd be 625, actually 625 times 10 to the negative 4. So it's just telling us to move this decimal place over 1, 2, 3, 4 places. And then I put 3 zeros in as placeholders. So if I'm rounding to the 4th place, I am going to look at this 9, because that's my 4th digit over to the right. That's the number that needs to be rounded. But I have to look at the 7 immediately to the right to make a decision. So that 7 is telling me add 1 to the 9. Well, 9 plus 1 is 10. So this is going to give me 0.0010. There's that 10 right there. Now that has been rounded to the 4th place. Okay, let's go over and do this last one. Well, this one is kind of crazy, but I can still do this. So I'm going to take the square root of 5 raised to the square root of 6. All right, so I'm going to first, let me see, hit second squared, put in the 5. So there's my square root of 5. And I'm going to raise this to, actually, it doesn't matter if your exponent is inside or outside, so I can leave it there, to the square root of 6. There we go. Enter. And that gives me this 7.17893. So the 4th digit is the 9. I look to the 3, which is less than 5. So that means I leave this as 7.1789. There we go. All right. Let's now move on. So you know how to put these into your calculator. So now let's move on and look at our graph of exponential functions. So you can see with our top graph to the right, it's kind of swooping. If you're looking from left to right, it kind of swoops up. That's what your blue one looks like. The red one, if you're going from left to right, kind of swoops down like a slide. All right, so let's look at some characteristics. So the graphs of exponential functions are defined by f of x is equal to b raised to the x power. All right. If b is greater than 1, then we say that that is an increasing exponential function. That's what we have here with this blue one. It is increasing because our base must be greater than 1. Sometimes this is referred to as a growth function. Now, if your base is between 0 and 1, okay, so that means if your base is a fraction, or if it's the decimal equivalent, okay, usually it would be a fraction though, a proper fraction, then we would say it's a decreasing exponential function or a decay. So that's what we have down here with our red graph. This one is decreasing, and so we call it a decay function. The domain for both of those functions is all real numbers. Okay, that's what our domain is. The range for both of them is from 0 to positive infinity. The x-axis, which is y equals 0, is what we refer to as a horizontal asymptote. So that means our graph gets really close, but doesn't go past that x-axis or doesn't go under that x-axis. It just hugs it. Okay, and then lastly, the functions pass through the point 0, 1. So with the blue one right there, we've got, there's our point 0, 1. And down here with our decay function, it's also going through the point 0, 1. Why is that? Well, if you substitute, if you've got your function, okay, f of x is equal to b raised to the x, and you put a 0 in right there for that x, we know that any number, any exponent, okay, so a base raised to the 0 power is going to give you 1. So that's why the y is equal to 1 when the x is equal to 0. All right, so let's just go ahead and do some of these. Let's plot some. So I'm going to start here with this blue graph, the one on the left, which is the function f of x is equal to 3 raised to the x plus 1. So our exponent is actually an expression. So let's go ahead and input for x. You can pick whatever your x you want. -2, -1, 0, 1, and a 2. So when I plug a -2 in, so I've got 3 raised to the -2 plus 1, that gives me 3 to the -1, which is going to be 1/3. That's what this, when you've got 3 to the -1, in order to make that 3 have a positive exponent, I would put it in the denominator and a 1 goes in the numerator. That's where that 1/3 comes from. If I've got 3 to the -1 plus 1, that's the same as 3 to the 0, which is 1. If I've got 3 to the 0 plus 1, that's 3 to the first, or 3. 3 to the 1 plus 1 is going to be 3 to the second, which is 9. And 3 to the 2 plus 1 is 3 cubed, or 27. So when I go ahead and plot those ordered pairs, -2, 1/3, right about there, -1, 1, 0, 3, 1, 9, and then 227 is off the chart. And so you can see how we go up. This should not have kind of flipped up. There we go. It just goes and hugs, gets closer and closer and closer to that x-axis. All right. So this one, even before we began sketching it, I should have been able to look at that base and see that my base is greater than 1. It's actually a 3. And so that indicates that it's going to be a growth curve where it kind of swoops up. And that, sure enough, that's what we've got. Now, when I look at this next one, before I even start, I see that I have a fraction as my base. So I'm going to expect this one to be where my base is between 0 and 1. It's a fraction. That's going to give me a decay curve. So that's where it's going to swoop down. So if I go ahead and put in for my x's, -2, -1, 0, 1, 2. Just random numbers, easy to do calculations. So if I've got 1/4 to the -2, okay, that is going to give me the same as 4 squared, or 16. If I have 1/4 to the -1, that's the same as 4 to the first, or 4. If I have 1/4 to the 0, anything to the 0 is 1. If I have 1/4 to the first, that's just 1/4. 1/4 squared is going to be 1/16. All right. So when I plot those, well, negative 2, 16 off the chart. Let's start with the next one. Negative 1, 4, 0, 1, 1, 1/4, and 2, 1/16. We get closer and closer and closer. All right, so that one, we've got our curve. Oops, and it would go just like that. All right. And that's what this one would look like. And that makes sense. It's what we expected. All right. This was just short. Just wanted you to get a good sense of what an exponential function is. You know what it is. So now you can do your homework.